Algebra students, Mr. Lawrence here with your video for over spring break. Hopefully you watch this. I know some of you are going to come in unprepared and you're going to fall behind. I'm just going to start leaving you behind because there's nothing else I can do. You don't want to do the work that it takes to be successful. There's really nothing I can do. But I will pay attention to those of you that are doing your best and trying to master stuff. We're going to be covering transformations the next couple of days. Transformations include translations, reflections, rotations, and dilations. We won't be doing dilations for a couple of days. We'll focus the first 2 days on translations, reflections, and rotations. This should be review, but some of you probably didn't master it last year. Now, hopefully you're more mature and you're ready to try it, because the first 2 translations or reflections are simple. And if you use the techniques I show you, there will be nothing to them. And the way I teach you to do rotations, that is also simple. If you're doing your best and you give a real effort, you will have no problem mastering it. I got to tell you, my pre-algebra kids already know how to do it. So, if you're telling me it's too hard or you can't do it, I say those are just excuses. All right, I'm done lecturing. Let's get on with the lesson. All right, so translation is just a movement. It tells you how to move the given shape. Here we have a flag. Well, in this case, we're, sorry, my music stopped playing. In this case, we're going to translate the flag up 2 units and right 5 units. Okay, we can see I put points at the corners. Now on an OAA or something like that, by the way, the OAA and the final are coming up very quickly. So you need to be doing your best to master this material. The points won't be given to you, but you can go ahead and put them on. You're given a shape on a grid. Well, mark points. Call them ABC, XYZ, anything like that. Okay, now we said we're going to translate up 2 and right 5. Well, that just means this shape is going to slide up 2 and right 5. If I move point A up 2 and right 1, 2, 3, 4, 5, I get the location of the new point A, which I will call A prime. B will move up 2 and right 1, 2, 3, 4, 5. And it's the location of the new point B, which is called B prime. And then C will go up 2 and right 1, 2, 3, 4, 5. And if you follow the techniques I give you, the shapes will draw themselves. Okay? Now, I don't care if you can't rotate things around in your head or you can't see them. Just follow the techniques I'm showing you, and these things will draw themselves. Okay, now we might also see a translation of, say, -3 3/2. Okay, remember slope is rise over run, and so in this case I'm going to go down 3 and then right 2. Okay, so point A would go down 1, 2, 3, and then right 1, 2. And that A I'll call A double prime. B is going to go down 1, 2, 3, and then right 1, 2. There's B double prime. And then C down 1, 2, 3, right 1, 2, and there's the new C. And you should be able to see this shape already, but if you can't, just go A to B, B to C, and then C goes back to the pole. Just follow the alphabet. All right, that's enough about translations. Reflections. Reflections are super simple. You just have to know where the mirror is. Now, I want to ask you a question. When you look at yourself in the mirror, where does your image appear to be? Well, it appears to be on the other side of the mirror, doesn't it? Like into the mirror? Now, obviously, that's only an optical illusion. But something you may never have thought about. If you're 1 foot away from the mirror, how far are you from your own image? And some of you are thinking 1 foot, and you're absolutely incorrect. You're 2 feet away. Because you are 1 foot away from the mirror, your image appears to be 1 foot into the mirror. Try it. Put your nose up against a mirror. If you have a full-length mirror in your house, one where you can, see your full body, that works best, especially if there's a lot of room where you can back up. Put your nose up against the mirror, and you can only see part of your face, but it appears to be normal size. then slowly back away from the mirror. Now your image should get smaller because things diminish in size with distance, right? But what you may not realize is you don't just look smaller, you look like almost smaller than you should be. And that's because the distance is doubled. If you back up 5 feet, your image is 10 feet away from you. 5 feet for your eye to the mirror, and then 5 feet into the mirror where the image is. So it's like looking at a person the same size and shape as you, that's 10 feet away. Okay, or if you go 20 feet away, now that person's 40 feet away. When you're talking 40 feet away, that's a pretty big difference. We're talking a little over 13 yards. 13 yards is a big distance. Imagine if you were 100 feet away, that's like them being 200 feet away. Okay, so I'm going to ask you to reflect this flag, the black flag there. You can probably see part of a green flag hiding down there. That's for the next problem. We're going to reflect it across the line x equals 2. Now, you're in honors algebra or regular algebra. You can't get this wrong anymore. It is not okay for you to not know how to do this. I can bring some pre-algebra kids in and they'll tell you how to do it. Hold on one second. If you don't know what kind of line x equals 2 is, then you are to write down 2 points. You can write down 3 if you want, but 2 is the bare minimum. It says that x must be 2. Well, then you put, sorry, I was talking about 2 so much I wrote it 2. Then you must make x 2. Now y can be any number you want. Now x has to be 2. If you write 0 again, which some of you do, and it just drives me up and down a wall. If you write 0 again, you haven't given me 2 points. You've given me the same point twice. That's not the same thing. You have to pick a different y coordinate. Can y be anything? Yes. Can x be anything? No. Why not? Because x equals 2. In both points, you have an x coordinate and a y coordinate. Right? X comes before y in the alphabet. This equation says x equals 2. I could have written down 275. Now that wouldn't fit on my graph, but I could have done it. I could have written down 2, negative 3,145 and 1/10. As long as x is 2, I'm on this line. Okay, so I'm going to plot the point 2, 0, which is right here on the x-axis, and then 2, 3 would be there. My mirror must be through those 2 points. So I'm going to put my mirror in here, and I'll make that mirror a little thinner. Now, just like you pressed up against the mirror or backing away from it, you find some points on your mirror. For example, this will be point A. We'll make this one point B. And then point C will be right there. And I'm going to count the distance to the mirror. A is 2 spaces from the mirror. It's perpendicular to it, isn't it? I'm going to go 2 spaces on this side of the mirror. There is A prime. Okay. B is 1, 2, 3. The new B must be 1, 2, 3 spaces away. Now, by the way, A connects to B, right? Well, that means that A prime will connect to B prime. I've got part of my flag drawn. Okay, let's go back here. C is 1, 2, 3, 4 spaces away. 1, 2, 3, 4 spaces away for C prime. And I know that B connects to C. And I also know C goes back to segment AB horizontally. There you go. There's your reflection. Does it make sense? Well, sure. If this is some kind of creature, let me put an eye on it. Okay, maybe it's a mouse. Okay, it looks kind of like a mouse to me. Here's in here, here's the nose. And the mouse is facing away from the mirror, right? Wouldn't its image, sorry about that, I had to stop to sneeze, that's why I'm repeating myself, be facing away from the mirror, right? If you were looking at the mouse and you could see its back in the mirror, right? You'd see its back as a reflection. Okay, this is simple stuff. Now, maybe this one here, we're going to reflect across the line y equals negative 4. Okay, again, you got to find the mirror. If you can find the mirror, these are cake. You don't know where the mirror is, you make 2 points. What's the only rule? In this case, y must be negative 4. X can be any number you want it to be. 0 and negative 1. So I go to 0, negative 4, 1, 2, 3, 4. I go to negative 1, negative 4. And there is my mirror. I'll put this mirror in a different color. Now, I didn't mark my points on here, so I need to do that. We'll call that point A. Oh, I'll tell you what, we'll call it something else since we already used A, B, and C. We'll call that X. We'll call that Y. And we'll call that Z. So my new points, X is 2 below the mirror. The new X must be 2 above the mirror. There's X prime. Y is 2 above. Y prime must be 2 below. Z is 1 above. Z prime must be 1 below. And if I just follow the pattern, X prime to Y prime, because X went to Y, Y prime to Z prime, because Y went to Z, and then Z prime back to the original segment, there you go, I get the mirror image. That's easy. Nothing difficult. All right, we're going to do 180-degree rotations next. Now this one, if you know your coordinates, it's simple. Let me mark down point A, B, C. And I realize some of you can do these in your mind. If you can do them in your mind, I could care less if you use my techniques. If you can't do them in your mind, or if you're getting them wrong, then I insist that you try my techniques. Point A is located at 1, negative 3. Point B is located at 2, negative 4. C is at 2, negative 3. And D is at 1, 2, 3, 4, 5, 0. E is at 5, negative 1. And then F is at 4, 0. Okay, here's how easy a 180-degree rotation. To get a 180-degree rotation, okay, 180 degrees, all you do is switch your signs. That's it. Just switch your signs. A prime becomes negative 1, positive 3. I didn't switch the sign on the 1 and the 3. 1 was positive, so I made it negative. 3 was negative, I made it positive. B prime becomes negative 2, positive 4. C prime becomes negative 2, positive 3. D prime becomes negative 5, 0. 0 is neutral, so it doesn't change signs. E prime becomes negative 5, positive 1. F prime becomes negative 4, 0. Now watch, I'm going to plot it, and this arrow is going to draw itself, and it's going to be perfect. And right now it's pointing up to the right. It's going to be pointing down to the left. It's going to go on 180 degrees around the origin. So watch this. So negative 1, 1, 2, 3. There is A prime. B prime is at negative 2, 4. Oops. I started to write a 4 there, sorry. C prime is at negative 2, negative 3. There's C prime. Now, if you want to start drawing your shape, you can. Please note that A went to C. So A prime goes to C prime. B goes to C. So B prime goes to C prime. See how simple it is? This thing starts to draw itself. Okay. D goes to negative 5, 0. 1, 2, 3, 4, 5, 0. Right there. D prime. And if I want, I can connect C to D. C prime to D prime. Boom. Now some of you are going to go, hey, can I just finish the shape? Sure you can, absolutely. I'm not going to just finish, I'm going to plot my points. This will be E prime, negative 5, 1. And then F prime will be negative 4, 0. And there we go. Simplicity. Too easy. And there it is. It rotated 180 degrees around the origin. The origin is at the center. And all I had to do was change the signs. Okay, I'm going to give you one more of those. I'm going to erase these. Okay, I'm just going to take a simple shape like this. Looks like a wedge or maybe an angle. Okay, and I'll call that A. And then B. And then C. And I know the coordinates of A are at what? Negative 9, 8, 7, 6, 2, 3, 4. Negative 6, negative 4. B is at negative 2, negative 1. And C is at negative 3, negative 5, I believe. Now remember, for 180 degree rotation, all I do is switch the signs, not with each other. If it's a negative, I make it positive. If it's a positive, I make it negative. And so what I get, lost my comma there, sorry. A becomes positive 6, positive 4. 3, 4, 5, 6, 1, 2, 3, 4. B prime becomes positive 2, positive 1. And then C prime becomes 3, 5. 3, 1, 2, 3, 4, 5. And then I just connect the points. Okay? A to B, B to C. And there you go. I have the same exact shape. It doesn't look the same exact. Did I make a mistake? Let me check really quick here. 1, 2, 1. 1, 2, 1. Okay, I like B. 8, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Okay, that's good. And then C. 1, 2, 3, 4. Yeah, there's my mistake right there. C is at negative 4, negative 5. Now, did you notice what happened? I looked at my work and I proofread it, which allowed me to catch a simple error. That's something so many of you don't seem willing to do. You need to stop, take a minute, and check your work, because you will make simple mistakes. 1, 2, 3, 4. 1, 2, 3, 4, 5. So C really belongs there. And then this point goes like that. And there you go. Now it looks perfect. Okay? I didn't plan that mistake, but it was perfect timing to model for you what you need to do when something doesn't quite look right. Now, if you want, and you could double check, you could count your slope. I mean, B is down 1, back 2. B prime is up 1, right 2. Yeah, because it's 180 degrees. Okay, you could check it on A, B, and C. All right, so that's a 180 degree rotation. Now, a 90 degree rotation isn't really that much more difficult. I'm going to identify, there's point A, and let's see, its coordinates are what at 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So A is at 5, 5. Oops, negative 5, 5. B is going to be this point here, and that will be the points negative 5, 4. C will be this point here, and I'll go negative 6, 3. Point D, I'll make the nose of my quadrilateral, and that'll be negative 3, 2. So negative 3, 2. Okay, now to do a 90 degree rotation, I'm going to use the coordinates again. First of all, I have to know which way I'm going to do. I'll tell you what, I'll go both ways. First, I'm going to go clockwise. Okay, so we're going to do a 90 degree. Sorry, I'm having a heck of a time spelling clockwise. 90-degree clockwise rotation. Okay, now, by the way, I'm in quadrant 2, right? Quadrant 2 is negative positive. X is negative, Y is positive. If I go 90 degrees clockwise, I'm going to end up in quadrant 1, where both numbers are positive. Why am I talking about that? Because watch, here's what's going to happen. To do a 90-degree rotation, I'm going to switch, and I'm not going to start with A because that one isn't so easy to see, but let me get set up here. B prime, C prime, D prime. Okay, I'm going to start with D. You see the 3 and the 2? I'm going to have them switch places. Now, I said I was going to up in quadrant 1, so both signs will be positive. How do I know? Because I'm in quadrant 1. So the new D goes 1, 2, 1, 2, 3. Yeah, it's that easy. 90-degree rotation. See the negative 6 and the 3? They switch places, but because I'm ending up in quadrant 1, they both have to be positive. So D prime, or C prime, excuse me, will be at 3, 6. 1, 2, 3, 1, 2, 3, 4, 5, 6. So that'll be C prime. B, the 5 and the 4, switch places, and they're both positive. Why are they both positive? Because I'm in quadrant 1. 1, 2, 3, 4. 1, 2, 3, 4, 5. There's B prime. Now, by the way, see how BC, segment BC, is the diagonal of one of the squares? Won't that be the diagonal of one of the squares? Yeah. And it rotated 90 degrees, didn't it? Okay. A prime, the 5s will change places, and they'll both be positive. So we'll go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So there's A prime. And now the shape draws itself. A goes to B, B goes to C, C to D, and D back to A, and there you go. Now, if you don't believe me that that's a 90-degree rotation, okay, now, of course, the center is the origin, but if I just clone this guy and I turn him 90 degrees, look at that. It's perfect. How do I know I went 90 degrees? Well, look at the rectangle. See the rectangle? Okay, it's longer than it is tall. And then I turn it 90 degrees, and now it's taller than it is long. And it matches. It's off a smidgen because of human error. Okay, if you look and see, like, this thing here really should be drawn more like that. I did a better job. And see, it matches. So that's a 90 degrees clockwise rotation. Counterclockwise is done the same way. But one thing I want to do is, hold on a second. Okay, see this flag here? I drew it a little bit differently. And let me mark points A, B, C, and D. And notice it spans 2 quadrants. This is no different than what we did. We're going to go 90 degrees counterclockwise this time. Okay, so let's see. We're going to go 1, 2, 3, negative 3, 1, 2, 3, 4, 5. So negative 3, negative 5 is the location of A. B will be at negative 1, negative 4. C will be at 3, negative 2, right? 1, 2, 3, 1, 2. And then D will be at negative 3, negative 4. Okay. Now, we're going to go... Sorry. Can't seem to get rid of that. All right, there we go. All right, get you out of the way here. Okay. Now, you notice that A and B are in quadrant 3. In quadrant 3, is negative quadrant. Quadrant 4 is here. That's the positive negative quadrant, right? So when I rotate this 90 degrees counterclockwise, it's going this way. A and B are going to end up in quadrant 2. And if you remember, quadrant 2 is negative positive. C and D are going to be in 3 where they're both negative. So I'm going to take A and I'm going to switch position of the 3 and the 5. Now I'm in quadrant 2, so it's negative and a positive. B, I'm going to switch the position of the 4 and the 1, and the X is negative, the Y is positive. Now C, I'm still going to switch the position to 3, but since I was in quadrant 4, they're going to quadrant 3, they're both negative. And then D will function very much the same way. I'll switch the 3 and the 4, and I'll be in quadrant 3, so they're both negative. And then I'll graph these points. 1, 2, 3, 4, 5, 1, 2, 3. So that's A prime, B prime, negative 4, positive 1. Okay, C will be at negative 2, 1, 2, 3. There's C prime. And then D prime will be at negative 4, 1, 2, 3, 4, negative 3. And I'm encouraged by this because, look, C prime and D prime are exactly 2 units away from each other. C and D are exactly 2 units away from each other along a vertical line here, a horizontal line. Why? Because I rotated 90 degrees. So let's draw my segments. A is going through B and hitting C. C is going over to D. And then D is going back up to B. And there you go. Let me see if I can get rid of that B. It's in my way. And that is a 90-degree rotation counterclockwise. So, just to review, translation, right? Okay, so the things we talked about in the video, the translation. That's just movement up and down and or right or left. Just a slide. The shape slides. A reflection. It's just a mirror image. You find the mirror, you count the distance to the mirror, the points end up the same distance on the opposite side of the mirror. 180-degree rotation around the origin. You just switch the signs of each coordinate. Bam, and it does itself. 90-degree rotation around the origin. It doesn't matter if you're doing clockwise or counterclockwise. The x-coordinate and y-coordinate change places, like 3, 7 becomes 7, 3. But then you have to give the signs of the new quadrant. And remember, this should be total review. If you have a coordinate system, okay, quadrant 1 is here, positive, positive. Quadrant 2 is here. It's a negative x and a positive y. Quadrant 3 is down here. They're both negative. And then quadrant 4 is here, where you have a positive x and a negative y. And there you go. All right, that's your video for spring break. Mr. Lawrence signing off. Have a good night, everybody.